is designed as a review of advanced algebra topics. It's something that we would have done the day of our test on sequences and series, the second half of the hour. So just some quick review here on radicals, roots, exponents, and then we'll get going on to chapter number 5. So first question there says the opposite of the square root of 49. So we all know that that would be equal to the opposite of the square root of 49. So the square root of 49 is 7. So the answer would be -7. The cube root of -64 means what do I multiply by itself 3 times? That's our root, third root, to get a -64. So 4 times 4 times 4 is 64. So that would end up being -4. 81 to the 1/2. So remembering the 1/2 exponent means the square root. So that answer is going to be 9. The next question there is crossed out. It's -27 to the 1/3. One thing that we do not do is we do not raise a negative base to a fractional power. If we want to talk about the cube root or square root of a negative number, we'll use the radical sign. So this would be okay to write, but writing it as an exponent is not okay. Next one over here on the left is the square root of -4 squared. Because the squared is inside of the radical sign, we're going to square first. So it ends up being the square root of 16. So we end up with an answer of 4. A little different here. Obviously, we don't see parentheses. So what we have to be careful with is if we do not see the parentheses, that means we want the opposite of 4 squared. So the opposite of 4 squared is -16. So that answer would be non-real, or we could also say 4i since we've talked about those. The next one is a couple of things. One, it's dealing with this 1/2 exponent, and then we have 1/2 exponent applied to all 3 of those things. So we'll talk a little bit about those rules. So the first thing would be 9 to the 1/2. So that just means the square root of 9, which is 3. And then when I have a power to a power, the rule there is we're going to multiply exponents. So 4 times 1/2 would be second. So I get m to the 2. And then n to the -6 to the 1/2 would be n to the -3. And then the other thing to remember is that when we have a negative exponent, that means reciprocal. It's just on the n. So I would have 3m squared over n to the 3rd. And that would be if the direction said something like do not have any negative exponents in your answer. This would be what we're looking for. All right, simplest radical form. Simplest radical form, if you recall, is finding any perfect squares, or in this case, cubes, that are factors of what's underneath my radical. So in this one, I could say that 40 is 8 times 5, but that doesn't do me a whole lot of good because neither 8 nor 5 are perfect squares. So what I would probably want to look at is a perfect square that goes into 40. So I could rewrite that as the square root of 4 times the square root of 10. And the square root of 4 is exactly 2, and the square root of 10 is the square root of 10. For the square root of 75, I could simplify that by changing it to square root of 25 times the square root of 3, which would be 5 times the square root of 3. A difference here on number 3 is that I want to now find a perfect cube that's a factor of 32. So some perfect cube numbers would be 1 cubed is obviously 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed we're all the way past 32 already to 64. So this I would want to break up into the cube root of 8 times the cube root of 4. 8 times 4 is 32. And that would simplify to the cube root of 8 is exactly 2. Cube root of 4 is I don't know, so that would stay as the cube root of 4. Here we have some exponent rules to remember. So I've got x to the 3rd times x squared. The rule there is we're going to add exponents. Here I have xy to the 3rd. So remember that means xy times xy times xy. So it would be x to the 3rd, y to the 3rd. The next one here, I've got x squared to the 3rd. So we just did that one. That's where I'm going to multiply the exponent. And again, if you forget these, remember what this means. We always say when in doubt, write it out. This means up here, x times x times x times x times x. So that's how we get x to the 5th. This one means x squared times x squared times x squared. And that's how we can get x to the 6th. Next one, I have a quotient raised to a power. So here I'm going to apply the 3 to both of the numerator and denominator. So I get x to the 3rd over y to the 3rd. This one, I have x to the 8 over x to the 6. So imagine I'd have 8 x's being multiplied in my numerator, 6 x's being multiplied in my denominator. So I'd end up with everything canceling out from the denominator on the bottom, and I'd be left with x squared on the top, 2 x's being multiplied. And the last one here is to make sure we realize that these only work if I'm talking about multiplying and dividing. If I'm adding or subtracting, then we have to use the distributive property, because this really means x plus y, if I write it out, when in doubt, write it out, times. So that's really what it means. So how do I multiply those? I don't just multiply the x and the x. I do x times y, y times x, y times y. So I'd multiply these two things together, get that answer, and then multiply that times x plus y. So that would be the steps that we'd have to do there. Next slide are some special exponents. We've got a 0 exponent, we've got a negative exponent, and we've got fractional exponents. So one thing here is that anything to the 0 power that we're going to deal with is going to be 1. Difference on this one, look at there's no parentheses, so the 2, the exponent on the 2 is really a 1. So it's 2 to the 1st times x to the 0, which is 2 times 1, so that answer is going to be 2. The negative exponent means reciprocal, so this means 1 over x to the n. This means 1 over 5. And if I have a fraction, we're going to flip the fraction, take the reciprocal of it, and then apply a positive exponent. And since this is a fraction, we'll apply it to both the numerator and denominator. So 3 to the 3rd, 27, 2 to the 3rd is 8. X to the 1 over n, that means the nth root. So we use that nth root. So this is the square root of 100, so that's going to be 10. And this is the cube root of 64. What times itself 3 times would be 64, and that number would be 4. All right, some more exponent review. Here we've got x to the 4th raised to the 7th power, so the rule there would be to multiply exponents, so we'd have x to the 28th. Next one, r to the 15th divided by r to the 3rd. Subtract the exponents, that would give us r to the 12th. Next one, I've got 4a to the 5th times 6a to the 3rd. Remember, when we're multiplying, the order doesn't matter, so we could put the 4 and the 6 in the front, and then a to the 5th times a to the 3rd. Maybe that would make more sense to you. So I'm going to multiply the two coefficients to get 24, and then I'm going to add the two exponents to get a to the 8th. So make sure that you do it in that order. Here, negative 2x to the 3rd, and then all that to the 0 power, which would be a big old 1, and then times all of this to the negative 2. So I'm going to apply the rule where I take the negative 2 and apply it to all of the values that are inside of my parentheses here, because I'm multiplying. So I would have 3 to the negative 2 times x to the power to a power. Negative 2 times negative 2 would be a positive 4. And then y to the 2 times negative 2 would be negative 4. And then finally, I'm going to take that and I am going to put the values, so I only have positive exponents. So the 1 is just 1 time, so I don't even have to really be concerned with that. This 3 to the negative 2nd power is going to go in the denominator, and it's just 3 squared, so I would have a 9. X to the 4th is a positive exponent, so that's just going to stay where it is. So x to the 4th is going to be in the numerator, and y to the negative 4th is in the denominator, and then I can change the exponent to be positive. All right, next one here, I got negative 5c to the 3rd to the 2nd power over 10c to the 8th. So I'm going to simplify my numerator first. multiply negative 5c to the third times negative 5c to the third. So I'm going to end up with 5 times 5, or negative 5 times negative 5, so 25. And then c to the third times c to the third would get c to the sixth. My denominator, nothing there to simplify yet. And now I have 25 over 10, so I can deal with these numbers dividing just like I dealt with these multiplying up here. So 25 over 10, they have a common factor of 5. So I can take a 5 out of 25 and a 5 out of 10. And then I have c to the sixth over c to the eighth. Two ways to think about this. I can still do the subtraction like I did up on this one. 6 minus 8 is negative 2. C to the negative 2 would tell me it's going to be in the denominator. I can also just look at it and imagine if I wrote it out, I'd have 6 c's being multiplied on the top of my fraction and 8 c's being multiplied in my denominator. All 6 of these on the top would cancel out with 6 of them that are on the bottom, and I'd have 2 that are left over. The 2 that are left over are what I find in my answer over here. All right, and then x over y to the negative 2 times y over x to the fourth. So again, deal with the exponents first before multiplying. So I've got this negative 2 exponent, which means I'm going to do the reciprocal. And then I'm going to square all the terms. So I get y squared over x squared. And this y over x to the fourth means I'm going to take both of those to the fourth power. So times y to the fourth over x to the fourth. And now my rule is I have the same base. So now I can have that base and I can add the exponents. So y to the sixth over x to the sixth would be my final answer for that one. All right, remembering some things about the graph. So just remembering the shape, and we're talking about the shape because we want to talk about how many answers we're going to have when we're solving these different type of solutions, and some confusion that also comes up. So y equals x squared, we know that's going to be our parabola U-shaped graph. And then what we know is that this x to the fourth is going to have a similar shape because when I take a negative number and multiply it an even number of times, it's going to end up as positive. So it's still going to be this particular shape. It does go up faster when I get to the right of 1 and left of negative 1, but it actually is a little flatter between negative 1 and 1. And then for y equals x to the sixth, same idea. And again, I'm just looking at the shape. The shape of the graph, sometimes students get confused. This is the only one that is called a parabola. X squared, a quadratic, is a parabola. The other ones you could say are parabola shaped or U-shaped, but we save that word for the x squared graphs. This one's going to be is cubic. So our cubic graph, remember, is the disco or the snake shape, however you want to call that. So I've got that shape. And then that one is just going to be the same for the x to the fifth, and it would also be the same for the x to the seventh. So that's our shape. And the idea is here that you notice we don't have any answers down here for the negatives. Here we do. We have one answer when it's negative, one crossing, and we also have one crossing when it's positive. Up here we have 2 crossings. So we'll talk about what that means when we're solving and also talk about what that means when we look at the roots as well. All right, so roots are solutions to equations. So x squared equals 81. If I think back to this is going to hit 81 twice. So I've got 2 answers. I've got 9 or negative 9. Y to the third equals negative 8. So that one, y to the third, y equals x to the third. So negative 8 is down here. It's going to hit once. And that value would be at negative 2. Z to the fourth equals 625. So that fourth power, that's that U shape still. So I'm going to have 2 answers for this one. I could plug in a 5, or I could plug in negative 5. That W to the fifth power is the snake shaped or cubic looking graph. Again, it's to the fifth. So that number, the only one that works for W for that one would be a 2. So what makes something an nth root? B is an nth root of x if and only if b to the n equals x. And it's going to be an integer. We only talk about like square roots or third roots or fourth roots or fifth roots. These are going to be whole numbers bigger than 1. All right, so even roots, when n is even, if I'm talking about an nth root and it is even, we just talked about our graph before. So it's going to be that shape. So here, if I have a positive number that my value to the fourth power is going to be equal to, I know that I would have two answers. There can be two numbers to the fourth power that would equal 16. Two numbers to the second power that would equal 9. There's only one answer to the sixth power that's going to equal 0, and that's just once right there. And x squared equals -4, that never happens on this real numbers when I'm looking at a coordinate grid. So there are no real second roots of -4. So make sure we understand. There are two numbers to the fourth that equal 16. However, if I'm just talking about this symbol, the fourth root of 16, the fourth root of 16 is one value. That number is 2. This is talking about what we call the principal root. The principal root is going to be the positive root. So this answer is only 2. And one way to think about that is think back to the graph. What does the square root function graph look like? The square root function graph looks like that. So how many times does this graph hit 9? It hits 9 once, right there at 3. So I want to make sure I understand that that square root function or fourth root function has one answer. Different than answering this question, because this is saying what number can I plug in for x and take it to the fourth power and have it equal 16. This graph is the one that looks like this. How many times does that graph hit 16? Twice. So a little bit of just thinking about the graph can maybe help you figure out how many solutions you're supposed to have, because oftentimes students mess up on these, and that's something we don't want it to happen for you. When n is odd, there's exactly one solution, no matter if I have a positive value or a negative value or if I'm at 0. It's going to hit once every time. A horizontal line with that graph once every time. So if I'm solving, here I'm asked to solve. So I want to get x by itself. So I have to subtract 2. And I get x squared equals 12. Get rid of the square by taking the square root, and right when I do that, I get my two answers. So x equals plus or minus the square root of 12. That's why we have to write the plus or minus there, to know that we actually want both of the answers. And then the square root of 12 I could write as 4 times 3, the square root of 4 times the square root of 3. So the square root of 4 is exactly 2, and the square root of 3 is, I don't know what that is. So there's my answer for number 1. Number 2, first step here is dividing by 2. So I get the cube root of x equals 10, and then I cube both sides. So I get x equals 1,000. So here, if I have a power, I know how to undo that. If I have a root, I know how to undo that. Here I have 4 to the x equals 256. 4 to the x equals 256. Well, I can't take an x the root. We're going to have to talk about this on the next particular lesson, but I could try to just do 4 times 4 times 4 times 4 and figure out what exponent I need. And I think for that one, if I do 4 to the fourth, I end up with 256. So we'll have to find a different method besides guess and check, because what if I change this number to a 250? That's going to be something I don't want to use guess and check for. So we'll figure that out in a little bit.